Hey everyone, in this problem we want to find how far a point on the edge of the wheel moves if the wheel is rotated through, and then we're given several different amounts of a turning point. So for this problem, well first let's start with part A, but for this problem we're going to want to use the same formula for all three parts, because recall that S, the tangential distance through which a point moves in circular motion, is equal to the radius of its rotational path multiplied by theta, the angle it moves through. Keep in mind that this formula only works if theta is given in radians. So let's start with part A, which asks about the wheel being rotated through 30 degrees. So first of all, r is 4.1 meters, since we're told that 4.1 meters is the radius of the wheel, and all three parts of the problem ask about a point on the edge of the wheel, so in other words, the radius of its rotation is just going to be the radius of the wheel. So 4.1 meters, and then multiplied by an angle of 30 degrees. Like I said a second ago, though, we're going to have to convert this from degrees into radians. So we apply the conversion factor, where pi radians is equivalent to 180 degrees. And then we'll put that into a calculator and find a value for S of 2.1 meters. And that's part A. Now let's do part B. We're going to be using the exact same formula, except now we're going to be using a different value for theta. R is the same though, because the radius hasn't changed. But for part B, we're using an angle of 30 radians. Like I said, this formula is valid for when theta is in radians. So we don't have to do any conversions at all there. We just take 4.1 meters and multiply it by 30 radians. And then we'll get an S value of about 1.2 times 10 to the power of 2 meters. And that's the answer to part B. Now, part C, where our theta value is now 30 revolutions. So 30 full revolutions around the circle. Once again, r hasn't changed, it's 4.1 meters. But theta will have to be converted from revolutions into radians. So one revolution, one full rotation in a circular path, is equal to 2 pi radians. So we can multiply it by the conversion factor of 2 pi radians for one revolution. And if we put this into a calculator, then we find an S value of about 7.7 multiplied by 10 to the power of 2 meters. And that's the answer to part C. And that's it for this problem. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos like this. And if you have a question, leave a comment down below, and I'll do my best to help you out as best as I can. If you have a request for a future video, or you'd just like to hang out, my Discord server and my Twitch page are both linked in the description, so check those out if you'd like. That's all for now, and I hope you all have a lovely day. Bye-bye!